one more session which is for EV3 models. Like as you have gone through the EV3 brick and what exactly EV3 brick is and what all the components are there and how to program that. I'll be taking you through the models which you will be building using EV3 brick. So later, once the instructor shows you the instruction sheets and he gives you all the components related to EV3 and EV3 brick, you can build these models and all. Just like I'll be taking you through what exactly these models are and how they are used in real world and what all their applications and all. So you will understand using those. You will understand those things in this session. So first of all, there is a model called as radar. As you all are all aware of radar. What is radar? It is nothing but a radio detection and ranging, which is majorly used in airports or in naval field or in air force to detect the objects entering into particular or certain areas where because there will be a threat of some objects or some terrorist attacks and all, there these systems are implemented. You might have majorly it will be used in aerodromes, wherein like flight traffic will be maintained using radars. This is nothing but radar is nothing but a technology where it detects an object in certain radius, within certain radius. So if you implement this particular device or mechanism at some place and certain radius will be covered by this device called as radar, which detects any object which is entering into that area, wherever like if it is assigned for some distance. So what it does is the technology behind this radar is nothing but it transmits signals and receives back. After those signals hits some obstacle and that directly it returns to the receiver end of the radar system. Because basically radar will be having two things. One is a transmitter and one more is a receiver, where transmitter transmits the signal and this signal as a packet it travels in certain direction, and once it hits some obstacle which comes in its path, it bounces back to the receiver end of the radar. So this is how, like using this, you can detect the distance of the object, and even these radars gives an image of that particular object, how it looks like, by sending those signals back from the obstacle where it hits that obstacle. So here you can see this is a flight which is entering to the area of an airport, wherein like there will be traffic will be managed depending on which flight is coming, and the other flight should take off or it should wait until it lands. So those things will be managed using the radar system in aerodrome. So this states that radar antenna transmits pulses of radio waves or microwaves which bounce off any object in their path. So as I said, these radars transmit the pulses of radio waves or microwaves which travel in a particular path, and whenever it hits to that obstacle, it bounces back. So this is the real radar antenna, which you will find it in the area where the radar has been implemented. This is called as dish antenna of the radar, and similar to that, this is our model using EV3, which is a radar model which you will be building using the instruction sheets once you start building the models. So this is nothing but like same whatever this particular radar does in real world, same application can be like shown or can be done using this radar here. So there are different concepts which you will be learning using radar system, like the distance travel, the time, angular movement, gear mechanism, speed, acoustics. These are the these are some topics you will be understanding using a radar system. So basically the gear mechanism, like we will be using the gear mechanism below that a radar model, which makes that radar to rotate. Usually this, whatever the antenna you saw, the radar antenna, it rotates in some direction. So every time continuously it will be rotating. So for rotation and all, we will be using the gears, which makes that particular radar to rotate in certain speed, which can be controlled. The gear, basically these gears are nothing but speed control devices. Like it controls the speed of any devices. Like you might have, you are all aware of vehicle gears and all. The same gear mechanism is implemented in different places for different mechanism or different task using that. Can be. So this is how different gear systems work. This is just an like example of a gear system, wherein like you might have seen in vehicles, vehicle lever, there will be different gears. These are all nothing but speed control. The basic mechanism behind this particular lever is this. This is the combination of gears which is used to make the speed increase the speed or decrease the speed. So that's why this gear mechanism is learned. So as you might have seen the radar applications and all, there are different higher studies for different higher studies and all. There are different options which you will be learning, like principles of radar, radar equations, Doppler effect, polarization. These are all the concepts which you will be learning in the engineering studies of studies related to. So this is a radar used in some military operations. So applications coming to the applications of radar is nothing but there, as I told you, they are used in military operation, remote sensing, air traffic control, aircraft safety and navigation, ship safety, space, miscellaneous applications like these. Even in the navigation side of it, like in ships also, same thing. The radar is called as sonar in the sea operation, wherein like it will be used. It is used to detect enemy ships or enemy submarines coming for attack. So there it will be not a radio wave. It will be a sound wave which is sent through the sea water, and it hits the, whenever it hits the obstacle, it reverts back. So that is called as sonar actually. So that is sound navigation and ranging. So this is what the radar is all about, and you will be building this particular radar model using EV3 to study these things, how it detects the object and how it creates the image of an object once it hits and returns back to the base point with the transmitter. Next model which you will be studying is an obstacle avoider. Is nothing but a robot which whenever it travels in some path, if something comes in front of it, it changes the direction. That is obstacle avoidance. Whenever an obstacle comes in between its path, it changes its direction. So this particular obstacle will be detected using the sensors attached to it. So there will be different sensors which does this task, like you can use the ultrasonic sensor, the IR sensor, or the touch sensor. So these are all different sensors which you can put it to your model. So like you can see here, there is an ultrasonic sensor placed here, a color sensor is placed, touch sensor is placed, but this particular ultrasonic sensor acts as an obstacle avoider for this model. So whenever this model is moving, if something comes in front of it, this ultrasonic sensor checks that, senses that particular obstacle, and the program is written in such a way that if the obstacle is in front, then it should take a right turn or left turn. So that is how it will be avoiding that path, and In the meantime, it is avoiding that obstacle which is coming in front of it. This is what the obstacle avoider flow, like what you can say algorithm or an flow chart of an obstacle avoider robot. So wherein it clearly shows you how this particular task is worked or how the particular task is performed by this particular robot. Whenever like it will be having some sensors, whenever it will be with the microcontroller, here in your model, the EV3 brick itself is a controller, and then there will be a motor to drive your robot, and there will be sensor and different, like there will be one or two motors which will be assigned for different directions, right turn, for left turn and all. So this is how the obstacle avoider works. Like once microcontroller senses, like microcontroller controls all these sensors and motors, and motor drives your robot, and whenever it senses some obstacle, it makes the right motor to take turn or left motor to take turn. So this is basically this is mainly used in some places where human can't go, where some information has to be collected. So those places obstacle avoider can be. So this is actual flow chart of an obstacle avoider robot. Like when you are programming, that time you will be creating many flow charts and all. So this states how it works. Like once from start point to stop point. Once you start, the motor moves. Motor makes it to move in straight direction. There will be if obstacle is detected, then it has to take a decision whether to take a left turn or right turn. If there is no obstacle, then it should move forward continuously, and then it should reach to the stop point. It is just a flow chart which can be put in an infinite loop so that it will be moved in continuously. So the major applications of obstacle avoider is, this can be used for blind people to see. Like it can be placed some sensors can be placed to their stick or some vehicle which is made for them, and so that it detects some obstacle and then it changes the direction, or it gives an alert to the blind person to make him to change his to allow him to change his direction. So even like for on some robots you can place the temperature or pressure sensors, where which can be used for sensing some obstacles or making some some tasks to be changed by in some hazardous places where human cannot enter, and it should change the directions of, if it detects some low pressure area or some temperature increase is there, more temperature is there in that places, it can make the robot to change its direction and all. And one more major application of obstacle avoider is the Google vehicle. Google vehicle is nothing but there are some vehicles implemented in US by some major companies like Lexus, Audi and all. They have given one for R&D purpose some of their cars to implement this obstacle avoider, which is placed, the cameras are placed onto all the corners and top of this vehicle, which is an unmanned vehicle. There will not be any driver for this vehicle. This vehicle, it follows all the traffic rules, and without any accidents, this particular car is moving in US from past 6 to 7 years, where like this has traveled many kilometers, but it has not met with any accidents because of all this obstacle avoidance implemented on it with the sensors. So this is the major application which you can see for obstacle avoider in this real world. Coming to one more model is robotic arm, which you will be building. See, this is there are many application of robotic arms which is used in mainly in vehicle manufacturing plant, or the place in the place where some hot plates or some heated materials has to be picked and placed, or in some vehicle painting industry and all, this kind of arm structure will be there, which is used to do all that task which human can't do continuously. So that's the reason it will be placed in some such plants for those operations. The similar model can be built using the EV3 model which you have learned, and this is how the model will be later. Once you build it, you will be given an instruction sheet for this, like how to arrange these components, sensors, and all the motors to be fixed, and how it is connected to a EV3 brick. Then once you program this board for some particular task, it acts as a pick and place robot, which picks some material like this kept on the table, and it places it in some direction. Or you can put some wheels to it, so that it can be used to pick and place those particular materials and shift it to some other place. So there are different types of robotics arm, and what exactly robotic arm is, what I have explained you. There is nothing but which is used in different manufacturing plants and all to do some task. So there are different type of robotic arm used in different industries, like Cartesian robot, which you can see this will be in this shape, which is made with actuators. Actuators are nothing but the mechanical device, which gives some movement for the arm. Like whenever you are giving a movement to an arm like this, or to pick something, so some actuators can be used at this part, so that it makes that particular arm to move in any of the direction. Or whenever the actuators are nothing but, it will be having a spring type of structure or hydraulic structure, which makes something which pushes some part of the mechanical device to make it straight or bend. Similarly, there is cylindrical robot, which will be in this shape, because there will be two cylindrical type of mechanism is placed on this particular robot to do the same operation for drawing some design and all. So which this particular robotic arm does by putting some pen kind of structure. So this is called design as a SCARA robot. One more of its kind for doing pick and place work. So articulated robot is one more robotic arm used for assembly operations, die casting. So these are all the welding mechanism, and all in some mechanical industries such robots are used, which will be of 3 rotary joints. This is the end of these different model brief introduction to these models, which you will be building once the instructor gives you all the components and instruction sheets. Once you build these models and see how it works, you will understand how exactly these particular models are implemented in the real world. Thank you.